So with our newfound understanding of sine, cosine, and tangent, I wanted to briefly revisit the 45-45-90 and 30-60-90 fairly common right triangle situations. So real quick, if I made this 1 for each of them, the hypotenuse is 1 for each of them, find me these sides. I'd pause it and, right, I'll make boxes. Pause the video and go ahead and find the missing sides real quick. We know in a 45-45-90 that the key factor here is the square root of 2. And if we're going to the legs, we're going to divide by the square root of 2. So this would be 1 over square root of 2 for both of these because they're the same. In 30-60-90, the key thing I try to keep in mind is that the small side here is always half of the hypotenuse. So that'll be a half. And the number that gets me from there to there is multiplying, because right, this is longer, so that would make sense, multiplying by the square root of 3. So this is going to be a half times the square root of 3, which is square root of 3 over 2. That might not be a bad idea at this point. Let's just, let's see, it's got to be in here somewhere. There we go. Is to figure out what these are real quick in terms of decimals. Like obviously a half is 0.5. That's no big deal. But what about square root of 3 over 2? Well, let's see. 3 square root divided by 2 equals roughly 0.866. Meanwhile, 1 over the square root of 2, 1 divided by 2 square root, equals 0.707. I heard somewhere that in the early creation of airplanes, the Boeing, I think was 707, was one of the early airplanes, that the engineers used that number because this came up so often when they were making calculations. Little dorky inside joke. So, notice, let's go through, let's not notice yet, let's figure out what would, under these circumstances, let's use the 45-45-90, what would be the sine of a 45-degree angle based on what we see here? Well, it would be the opposite, which would be 1 over the square root of 2 over a fraction and a fraction, don't panic, the hypotenuse, which is 1. Or it would just be 1 over the square root of 2, or as a decimal, 0.707 is a good approximation. So literally, if you go to your calculator now, and assuming it's in degrees, and you type in this one I have to type the angle first, 45, and I hit sine, boom, there you go. The sine of a 45-degree angle is that. What about the cosine? Shouldn't have to think about it too long. It's got to be exactly the same, because it's the one situation where, since these angles are the same, the length of their opposite and their adjacents are the same. So cosine of this is also 1 over the square root of 2, or 0.707. And the tangent, interestingly enough, of a 45, well, what's it going to be? It's going to be this over opposite over adjacent. Well, wait a second, they're the same number. So anything over itself, 0.707, I'll do it quick version, divided by 0.707 is 1. So the tangent of a 45 is just 1. What about here? What about over here? In fact, let me do this. Let's go 0.866. And what about for the 30-60-90? So let's do the cosine of a 30-degree angle. And in fact, here, let's do the sine first. So the sine of a 30, the cosine of a 30, and the tangent of 30. And the sine of a 60, cosine of a 60, tangent of a 60. So sine is going to be opposite, which is a half, divided by the hypotenuse, which is 1, so that's just a half. Cosine is going to be the adjacent, square root of 3 over 2, divided by 1, which is just square root of 3 over 2. And what about the tangent? Well, that's interesting. That's going to be a half over square root of 3 over 2. So if you're not familiar how we handle something called a complex fraction, we take this bottom fraction and we flip it and multiply it times the top. So in other words, we'll take a half times 2 over the square root of 3. And that comes out to be, well, the 2's cancel, and that's 1 over the square root of 3. Now, what about the sine? Well, you could go up to the 60-degree angle and do it. In fact, I welcome you to do that. But keep in mind that the sine of a 30 is going to be the same as a cosine of a 60. So I'm predicting this is going to be a half. This will be square root of 3 over 2. And this will be this flipped. In other words, this will just be the square root of 3. You take this and you take its reciprocal and you'll get that. Double check. Now, you might be saying, well, that's great. It works for, think about this. I made that 1, so wouldn't that change how all this would work? I mean, when I divide by 1, it just makes it the opposite side, for example. So what if I just happened to make it something harder than 1? What if I made it a letter? What if I made it n? The hypotenuse is n. Oh boy. Well, would sine, cosine, and tangent values change? Think about it. Does the size of the triangle matter, or is it just the angles? Remember, it's just the angles. So really, this should work out. Let's do the 30, 60, 90. So let's say I want the sine of the 30-degree angle in this case. Well, this is going to be n over 2. This is going to be square root of 3 times n over 2. So that means, remember, I go from here to here, I'd cut it in half, and then from here to here, I'd multiply by square root of 3. That means the sine is going to be, of a 30 degrees, going to be the opposite, n over 2, divided by the hypotenuse, which is n. This comes out to be, by the way, n over 2n. The n's cancel, and I end up with a half. So you see, it doesn't matter what the hypotenuse is. If this is a 30 degree, what matters is that's a 30-degree angle in a right triangle, then the sine of a 30-degree angle will always come out to be a half. Likewise, you can prove it to yourself, but the cosine of a 30 is going to be the adjacent, square root of 3 times n over 2, divided by the hypotenuse, which is n, and once again, the n's are going to go away, and I just have square root of 3 over 2. So, regardless of what the hypotenuses are, the sine, cosine, and the size of the triangle, the sine of a 30 is always going to be the sine of a 30-degree angle. Doesn't matter really what sides you start with. And likewise for the 45, 45. A little bit of memorization, once again, will go a long way on this one to help you out.